back. Hello, everyone, and we are back.
Hi
Ciao, Matteo.
everyone. Hello. New platform, new way, new everything. Probably less technical issues this time, very happily. So I'm very happy to be back, Luca. Also, I received a new Platformatic T-shirt, you see, and then
Good,
I actually, put it to good use.
good. We celebrate a new start with a new outwear. Um, Today, we're going to talk about something cool, a little bit high tech.
Is it high tech? Come on.
Well, yeah, come on. It's not.
Okay,
It's,
high
it's
tech.
not like easy stuff. So, where do we start? That's a hard topic.
So the topic of today, Luca, is stateless versus stateful architectures, right?
Lovely.
And this is one of the most one of the biggest probably misconceptions that you can have in software engineering and in computer science, probably. Okay, so I have
Why
a
a
question for you, Luca.
Go,
because
go.
because stateful versus stateless happens at every level of the stack. So you can have something that is logically stateless, but in fact is based on a stateful protocol, and vice versa, which is fun. Okay. So now a question for you to start on this
Go.
topic. It's
Sure.
okay. Is HTTP stateful?
Is HTTP stateful? Well, it keeps the connection, so is by definition stateful.
But REST
But REST, well,
is not.
is stateless. Yeah.
It's stateless. Okay, so that's the key part. Okay, that's the first distinction that I want to people to make. When you interact with an HTTP API, usually you send a request, you get a response. Okay, and we call it stateless. What does it mean? Okay, it means that if there are 5 servers, I can send my message to each one of them, and they will all act in the same way. Okay. If one time I talk to one server, it does some things. Then the next time I talk to the server next, it's the same. Okay, everything is the same. Okay, it doesn't matter which server I talk to, I always get the same response. Okay, which is fantastic. Okay, but then HTTP, okay, on top of HTTP, you can build something like WebSockets, which we talked last time, okay, SSC, and a bunch of other stuff, which make things essentially stateful, okay? So it's fun to talk a little about that way. I try to, it's very, I don't know, subtle to some extent when you want one or versus want the other, okay? Because with now I have a more question for you. Is it good or bad? So is a database connection stateful?
A database connection to
Yes.
which database?
Oh,
To
a
any
SQL
database?
database, any database.
That's actually a good one. With a SQL database, clearly from Node, right?
Yeah.
Because the cheating is that from Java is stateful, but from Node.
But also from Node is stateful. The protocols are usually stateful because typically when you connecting to a database, you need to authenticate yourself. Okay, you go, you run a few exchange, you send out your connect, you do a TLS exchange, then you send username and password, you select a database that you want to work on. The schema, sorry, depends on the product you're using. You can have call the schema or database, it doesn't matter, but you select the portion of the data you want to work on, and then you can issue your queries based on your username level and so on and so forth. That's stateful. Okay, so yeah, it's
yeah, but I mean, I think when we look at stateful, like you were saying, there are different levels. I don't think the protocols demands the architecture, right? I can
no,
still build
absolutely.
a stateful architecture with a completely stateless protocol.
Exactly, but you need to know, like the fundamental point that I'm making all these examples. Okay, it's because people need to understand about what is stateless and what is stateful at every single time that they do some interaction and make those decisions accordingly. Because if they start to use something that they think is stateful, when treating it in a stateless matter, that will hurt a lot.
Yeah, but if you think about databases, right? I mean, the connection is stateful because of the credentials, clearly.
Yeah.
But then it makes the whole chain stateful, because unless you don't create the same connection across multiple peers and you make it single tenant, then you are kind of like forced to shard or partition based on your connection, your credential.
Yep.
So you're still going to be full stack stateful in that sense. But I mean, that's a kind of interesting point, because we are building most of the time even simple systems, right? Like a website, an e-commerce, or and there are different ways to solve the state, right? In that case, right? Imagine that I jump into an e-commerce and I add the product on my shopping cart.
Yeah.
And then how do I actually store my state? Because imagine I close my imagine Amazon, for example, right?
Yes.
I put stuff from my phone, I open my web browser, and still I see my stuff in the shopping cart, right?
Oh gosh.
Well, luckily, because I would not like to go from the phone to the browser and have to re-add everything. But that's actually one way, right, to consider state when you look in e-commerce.
Yeah, it's so much fun. A lot of years ago, okay, when designing e-commerce, when I was studying this kind of stuff at university, okay, somebody brought the fact that shopping cart in an e-commerce, okay, should be should be stateless, okay, and related to the device that things are being added on. However, what you want is the behavior you just described, Luca, which is that my state is stored across all my devices and shared. Okay, so it's very interesting, because there is one case that a lot of e-commerces I've seen generically do very wrong. Okay, which is the transition from not logged in user to login user. This is one of the things that most e-commerce do wrong. Okay, so let's put it this way: you open up your e-commerce, you're not logged in, your new product. You logged in, okay? You have the cart. You want to provide no signed up experience, okay? So you have a cart, okay? Now you have this cart. Now the question comes: you have two options here, okay? So either every time you create a user session for each anonymous users coming in, okay, and you create some cart objects on disk on your databases, okay, which then leads a massive amount of cart objects that are available, okay, or or you store them in cookies and then you upgrade them, and then you need to decide how to upgrade them. In any case, you need to convert that anonymous cart to a named cart when the user sign in, okay? Or you want to say, oh, the user is signing in from here. Probably the things that he added on the cart, I need to transfer it from this cart to the user's cart on disk, which is a different cart. Now, a lot of people that have not done implemented a few e-commerces implement this so much wrong. This is one of the hard, and this is actually a money loser flow, okay? Because if I'm not logged in and I'm logging in, if I lose things from the cart, very unlikely that I'm putting them back in and buy. I just throw away my phone, to be honest.
Yeah, but most of the time you can also kind of like force it from the user, that behavior, right? You can say when you add something in your shopping cart, you need to be logged in. That could be also
yeah, but it's not. That's an option. Anyway, I was working at this on this e-commerce, and the cart table, okay, ended up having, it was a table on a SQL database, and it ended up having, I think, more or less something like 20 million records.
Should be all right for a Postgres. It's not too
Yeah,
much.
but it was massive, okay? And it was, the point is that creating any, and they had a lot of indexes in it, and that adding ones was actually very expensive, ended up being very expensive. So it was not fun at all to deal with that. It was very easy to remove, okay? This was very easy because you can actually remove, I don't know, maybe infinite ones, because most of them were for anonymous users. So,
And I mean, I think now we are looking at kind of like very linear use case, right? I'm building
yes,
state for like let's say a simple system.
yes,
But I was kind of like impressed at the time that I kind of like was closer to the Uber team to see how back in 2016, so already obsolete, state was actually thought. Like imagine that you have all these drivers that are going around
yeah,
the city and so on. Let's keep the way the map is generated and they're stored, but there is a continuous state change for all these,
yes,
right, for this driver. And when you need to dispatch, the search needs to be extremely fast. Like it needs to kind of like triangulate and do a lot of things. So that was actually for me a pretty interesting use case, like to see the first time on a different way on how a distributed system actually would handle state, which is kind of like how even Redis, right, handles the persistency at the state. I don't know. Do you want to drill down on something fun and look how distributed system they handle that?
So I want to talk about a seminal paper on this topic. Okay, it's the DynamoDB paper. You should all take a look at the DynamoDB paper. It's really good to read. Okay, it was written by Amazon for the first implementation of that thing. Okay,
By Werner Vogels, by the way.
it's a great paper. Okay,
Yeah.
it's how to manage state. Okay, so the key concept of that paper is you have some sort of controller. No, I don't remember the exact term. I didn't read the paper. I'm going from memory. Sorry, I should have read the paper before this call, but whatever. Anyhow, it goes with some sort of controller or entry point node that receives your request. Okay, and then from there it uses consistent hashing. Okay, to automatically to select based on some ID. Okay, which of your servers is going to handle that request. Okay, and by the rules of that are described on the paper and the math and so on and so forth, if it's not available on the first one and the first one is not available, you can also use the same algorithm to compute the next server in the ring. So it's a ring. All the servers have a peer, a previous and a next peer, and you can go to the next one, and the next one will have a replica of that day, of that value, because okay, in this way you can ensure that your system is always available and it supports also partitions. Okay, because we are going, and this is to go forward into the problem of all stateful systems, which are, most of them are in fact databases and therefore subjected to the CAP theorem. Luca, this is probably your realm too.
There is also one thing, right? In Dynamo, there are two things that are like clearly shards and partitions for data, and that's why the ring kind of like knows how to select the shard. Yeah, the CAP theorem, that it feels that is more kind of like a universal concept, right?
Yes.
Where we are always trying to achieve the impossible of achieving, consistency, availability, and tolerance all together, but we all know only two of them can be achieved at the same time, and the third one is to be sacrificed. It's kind of like interesting because at the time of Cosmos DB, the Azure version, I mean, there you can see the genius of, Dr. Lamport. Microsoft really tried to kind of achieve the three all together. We're using some
Well,
sort
you
of like
can
hack.
technically, but yes.
Yeah, but not in one go, and that's the thing, right? So that's where they cheated. The system is a complex system that can provide it. But by the way, I love Cosmos DB. I think it's an underrated database. But
I prefer Spanner, but yes.
but they solve two different things because Cosmos has this multifaceted kind of like interface where Spanner only solve like a key value.
Yes,
problem.
I know. But we should talk about Spanner before, because it's a phenomenal paper. So I will probably, this is another paper that you read if you're interested in this stuff, the Spanner paper.
Yeah, I think we mentioned last time, right, that Google has a couple of like insanely crazy systems like Bigtable, like it's like which is the clone of DynamoDB. Insane, like the way they achieve scalability is like unheard of. But we were talking about the consistent hash ring, so and the CAP theorem, the theorem of life. They should rename it into the theorem of life.
Fortishow.
Yeah, and I think what is kind of like interesting is that we kind of like segue on talking about like Redis, or nowadays Valky, but very kind of like interesting other system, right? Because it's key value storage, highly memory, extremely fast, and uses similar algorithm, right? Not really the same, but a similar algorithm. And there is another thing, actually, while we're talking about state, and we mentioned Lamport, we forgot about the most interesting thing about state consistency and state concurrency, our vector clock type. Yeah. Do you remember at the time in 2016, there was a database that decided to have as a primitive a vector clock primary key, React. I don't know, it disappeared. I never heard of React anymore. I don't know, have you heard of that?
I think it folded. But let's look. Let's take a look at on the interwebs. We can ask Grok.
I'm actually interested if the reason why then disappeared.
It's still there. It's React Enterprise NoSQL database. Okay. Product.
Yeah, the beauty is that vector clock, right? The key of that is the vector clock, because the problem with distributed state what is concurrency, right?
Yes.
What if there are two actors acting on the same state mutation?
It's still React is still around, Luca. It's totally still around.
Well, probably they fired the marketing department. I haven't heard of them in a while. I love them. I think it's a brilliant database. It's for the people who never actually play with it. It's basically, let's simplify it. It's like a Redis, but with a vector clock. And I think you mentioned a white paper right before. So there is another interesting paper that is how Lamport won the Alan Turing Award, which is with the vector clock definition. I think that's actually an interesting angle, right? Because we are touching the concept of state with the concept of location, right? Because the hash ring finds the location.
Yeah.
And the concept of concurrency with vector clock. So I think state is not such an easy thing when you enter the distributed system world, right? It's pretty complicated because we talk about CAP theorem. What do you do? Are you state consistent, state available, or state tolerant? So you are resilient to failure. So that's kind of like interesting because you mentioned the consistent hash ring. And I mean, you and I, you remember back in 2016?
Yeah.
We go back there. We played with the idea of building a system that was competing with Ringpop from Uber, but 10 orders of magnitude easier to use, because clearly when you enter the consistent hashing world, it's pretty complicated.
It's super hard. It's super hard to build this kind of system because in that model, okay, you have the So a traditional, a normal model, okay, when you work with a SQL database or anything, you have compute separate from storage. Okay, so you are your custom logic, your compute, okay, your custom logic is run somewhere. Okay, the data is not there. You make a network request to go to the data, and then you get the data. You process the data, and then you return that back. Okay, or you put the data back in the database if it's a process. But this is the flow. Okay, so this is decoupled. Okay, so the state is in the database, so your application is actually stateless. Okay, because there's nothing in memory related to that specific request. Perfect. Okay, a stateful system means that there is data in memory in that specific process or that specific host or that specific machine running. Can even be that specific hard disk. Okay, that is stored on that machine. Okay, that it is in a bay of that server. Okay, that contains some data that is specific for that user of that request. This is the problem. Okay, this is what we call, this is a stateful system. Okay, and it has that information there. Okay, now some stateful systems are things are connections. Okay, it's a socket. A TCP socket is a pure example of a stateful system. Okay, because it exists only on that operating system. It cannot exist anywhere else. Only in one operating system, on that specific instance of that operating system. You can migrate it. Okay, you can move it around. So that's stateful. Okay. Other systems are a file there is stateful. Okay, like a SQLite database, is the key things that is absolutely stateful. Okay, you can. Did you know that you can have multiple process read from the same SQL database file, but only one writing, Luca?
Yeah, it's because of the optimistic concurrency.
Yes, there is a optimistic concurrency logs and so on and so forth. It's great, okay? But this means that the system is stable. It's only on one host, okay, on that machine, okay? And if you want to replicate, you need to invent a solution. There's been infinite amount of companies in the last 3 years trying to solve this problem for SQLite, okay?
For SQLite, because I remember Oracle was making a good chunk of money back in the 80s with.
They're still making it. Like they're still making it. It's to be honest, that database. Once you install it, installing it, having the cluster works like clockwork is very hard. But once it's running, that thing is beautiful.
Yeah, the consistent write part. I think it's. I mean, there is a Sheila that can do it, or Cassandra that can really handle it. But in the SQL world, it's kind of like challenging to get it right.
Especially if you want to have more than one one option when you talk about state is the typical system is I have a leader and a bunch of followers. Okay. There was a previous term, okay, and it was called the master and the slaves, but that's the key. That's the same thing. Today we call them leaders and followers. And you have the leader that is typically elected around in some ways, okay, that synchronize all the things, okay, and then there are replicas, okay, and or followers, call them the way you want, and then there is some way in which the leader can be moved from one to another in case of a failure, okay. You can have systems that are human blessed and says, now you have been, I hereby crown you the leader of the database cluster. Okay. Well, this actually works extremely well. Okay. I have it's essentially it's a read-only or cold replica. Okay. If I want to make that the master, I can with a change of a config, but I'm not. I keep it as a read-only replica, so I can use it for reads. Okay. I cannot use it for writes. But apart from that, it's phenomenal, okay? It's a phenomenal system. So, but then there are systems to elect that leader and so on and so forth. So I have a question for you, Luca, okay? So how can we scale and manage stateful workloads?
What kind of workloads, though?
So the fundamental, the most common stateful workload that we have, and we talked a little bit last time, okay? It's about live connections or WebSockets or sending data to the end users. Okay. How do we do that? How do we scale it? How do we make it more manageable?
Well, I mean, the socket, we already gave the answer, right? We use a handshake model to keep the stateful connection between the client and the provider. I think it really depends on the I mean on the type of situation, but I think there are different ways that you can do it. You can use a cursor model, like where you maintain the state of the cursor on the client, and you basically summon it when you make the request to the server. So you flip the equation. Or I mean, it depends also on which appliance you want to use. Dynamo, for example, you mentioned it. You can use basically the same exact principle, but everything is server side, just because you have the hashing that is going to take care of reconnecting you to find the correct shard. Yeah, it really depends. There is also something. Now that you're asking about use cases, there is one use case that is kind of like interesting, that requires a more complicated solution. I personally think that is stateful orchestration, ergo workflows. Yes. And I remember when Uber switched to Cadence, I asked myself 100 times why. And after talking with the guys from Temporal, I finally kind of like realized, I got a eureka moment, and I said, that's interesting point of view. Like the concept that they use to handle state is pretty interesting. They imagine a transaction between a user and the system as an infinite state with infinite mutations. And I was like, huh. So it means that I start living when I join the platform, and I disappear from the state when I abandon the platform. And then I ask you this thing because I work at, we met when I was working in Amsterdam in Ice Mobile, and I was building this platform for digital loyalty. And we massively use Dynamo. I mean, let's not go into that. But what is interesting is the concept of loyalty. You know, when you go, for example, to a supermarket and you collect points.
Oh, yes. Points. You were really into points at that time, Luca. Are you still into points?
No, but we collected like we built this platform, and one thing that was interesting is that we took an approach that was fire and forget. Like we fired the point collection and so on, and basically we would just like mutate raw in a database. But the way, for example, Cadence or Temporal sees that is that this data lives in this forever transaction. So the concept of like stateful distributed transaction, long running, right? Because here is the time.
Yes, but that's the fundamental problem in workflow execution is, you cannot have a place in which you hold state, because like let's say that you have a workflow that can last, I don't know, 2, 3, 4, 5, 10 minutes, okay, and as part of that workflow you need to do multiple computations, call multiple systems, receive multiple results, and so on. You hardly can expect you cannot expect for a single process or a single piece of memory to be available for all that amount of time.
Yeah.
Like unfortunately, Murphy's law is here, and if something can go wrong, it will, and therefore that process will crash 100%, and therefore you will lose that state. So you need to be able to anytime restore that state anywhere. If you can restore that state anywhere, then you can absolutely 100%, okay, like shut it, like completely remove it from memory once that step is executed, and wait for the current step to complete. So you can actually say, okay, call me back when you are do this processing, call me back when you're finished, okay, and then the state would move. Okay, or even have a state in which, let's say, wait for that callback. Okay, it's coming as a callback. Wait for that callback. Okay, that's a state.
And I think workflows they are very interesting. I mean, I personally love the concept of. I personally feel that workflows are a very interesting computational problem to solve. I don't know. They are boring for many people because they're. Do you remember at the old time when you build all integration systems, and probably back in the 90s, 2000, there was a system from Microsoft called Bitstock, or Oracle as ESB. Those ones that were kind of like the same. They were workflows for integration. And it's kind of interesting when the transaction breaks, how to recover state. So they call it a state rehydration, which is a beautiful thing. Like, how do you rehydrate state? And you and I kind of like had this conversation when we were building our caching system in Platformatic. Like, what is the best way to hydrate state preemptively in a system? Can we basically inject this kind of cache ahead of time? So we have basically some sort of like state of the cache, and we hydrated those pods. So I think when we talk about stateful system, what I really see is an evolution, right? And that's how we started from the microservices point where everything needed to become stateless because there was this kind of like decoupling. But time is telling us that basically we can't actually break state. State is something that I mean, you can call it is physically present in any rational thought that we have. Even if you think, and you were just saying, stateless system, they might be stateful because they have a protocol that requires a live connection. And I think workflows, and correct me if I'm wrong, right? They were the interesting segue into something that today became extremely interesting, but extremely hipster, is the concept of memory, right? But I have a surprise.
Oh,
Yeah. So
what's a
you know that I
surprise?
love fountain pens.
Of course.
So there is an Italian maker called Montegrappa, and there was this trilogy that I was extremely inspired. I love the brain. I love those kind of things. And there was this trilogy called the Brain Trilogy. And one of the pieces is this one. It's called Memory. And I thought I would keep it here on my desk because I knew we would go into the world of like memory and the concept of state, because nowadays we talk a lot about AI, right?
Yeah.
And let's be very honest. Everyone talks about AI. AI is hipster. And what is the biggest problem to solve in AI is the concept of learning and memory, right?
Yeah.
Those two things. I mean, without stating the obvious, is the core of generative AI and like all this
Of
new
course,
wave.
Luca. It's state. All of this is state. Come on.
So when I was obsessed by finding this trilogy, I asked myself a question, and I said, is our memory the biggest and most complicated stateful system? And are we as humans the most complicated and intricate distributed stateful system? Think about interaction, you and I, our families and so on. We
Absolutely.
represent a distributed state, right, in real life.
Yes, absolutely. Absolutely. This is actually very thoughtful. And going a little bit into the AI analogy, the biggest problem that AI systems have these days is the management of context. Okay, telling the AI, okay, the AI, all these LLMs and stuff knows a lot of things. Okay, in fact, for a lot of things, they're way better at us are recalling it. For others, they completely hallucinate, and if you're not an expert, you wouldn't know. So it's so much fun just to watch. Okay, but the biggest problem, in fact, is giving them enough context to understand what to do and what the problem is. And very often you can, and because they don't learn, they learn at the beginning, but they don't learn about you. Okay, they don't learn about what you're talking about. Okay, they only have a very, very short attention span. Okay, and they don't recall what happened the day before. Okay, very often you start a new chat, they don't recall what you said in the previous chat. When I talk to you, you recall what I said one day ago, right, Luca? So that's what set aside today, what set aside us and humans. And I don't think that's. I think that's kind of unique. Okay, still, and something that is everybody that said that humans will be replaced by AIs. I don't think this happen anytime soon, mostly because of that. Okay, we will do more stuff done absolutely, be more productive, improve, market will go up, new industrial revolution, blah blah, whatever. But humans, well, humans are special in that sense. So I don't think that the current AI systems have that kind of capability yet.
Yeah, and if you think about the distributed system, like and this distributed transaction and state that we discussed, it's basically interesting how and you nailed it, right? You and I will always remember, well, with certain degrees of certainty, what we chatted today about. Right?
Yes.
Tomorrow we will remember it, and we will use it to have another conversation.
Yes.
When I was actually interacting with LLMs, I was very highly surprised on how there is a limitation in that sense. And I was thinking, is that because the data is too big to actually recollect them? Is that because the interaction, so the synapses between this data are super complicated? So the compute need to do that is way too much for the outcome that is required. To be honest, I make an assumption, and correct. I mean, probably you will have more depth there, but it is extremely complicated to have this tree of knowledge, traversable and categorize and put all together to give meaning to a context like you were
Well,
saying.
the point is, okay, and this is why stateful system are so much in vogue. Talking about stateful system is so much in vogue right now. Okay, and in fact, it's because when you are having a chat with your LLM, okay, or your AI system, in fact, you are interacting with a stateful system. You are interacting with something like all the things that you are discussing with the LLM with, and so on and so forth. All of that is the state of that conversation. And in order to keep responding to that state, he needs to answer, he needs to keep holding all that state in memory somewhere on some physical hardware. Now, moving that state from one machine to another is a lot of work because some of those chats can contain, I don't know, megabytes of data. Okay. And every time you need to do anything, an interaction with it, it needs to read all of that state, load it in memory, and process it to give you the next answer, which is where things gets very, very complex for that. And you see some of them at some point says, no, you can't do this anymore. You need to start a fresh chat or so on and so forth, because it's all about managing state, okay, and managing all this bunch of data that is related to that specific thing, but you need all that state to process the next one, okay? And we are seeing this resurgence on this topic, okay, on managing state, okay. Another one is about sync engines, okay, synchronization engines. This is another one where managing state is really a problem, okay. At some point, I thought that will take over. I was very much inspired by Google Wave, and I thought that pattern would essentially take over the web. In fact, it didn't, because it was way too complex to implement for the average developer that will never ever have the capacity to implement such a system, okay. And much more known collaborative patterns emerge. But this is why I don't know tools like Figma or Miro became massive companies because of those kind of
right? Yeah, the multiplayer functionality. So
the multiplayer multiplayer. When you see a multiplayer functionality, you are talking about stateful systems. How do you handle stateful systems with 100 participants, 1,000 participants, or games? Okay,
that video games, exactly.
Yeah,
I'm thinking about Half-Life or like whatever,
Yes.
Quake, you name them, Unreal. Yeah, that's actually very interesting because Yeah, that's actually extremely interesting. I was just thinking that one of the complicated thing about state, and we mentioned before, is concurrency, right?
Yes.
And there are systems like Miro, for example, like let's
Yeah.
think, or Figma, you name them, where concurrency is handled, I think, in an extremely smart way, right? With the causality in mind, but for a second, back to LLM, and I don't want to go too much there and go too metaphysical, but it's kind of interesting how there is a huge gap between the complexity of handling a certain context of state versus another one, right?
Wow.
Because there is conscience in between, right? Is that the right thing to do, to overwrite that thought, that memory block, or shall I just skip it, right? While other systems, they use purely optimistic concurrency, or they use like causality, and it's okay. Like in Figma, right? If you and I change color, you change color, and then I change color, bless. The system doesn't really care, right? The system is just like a state machine. It's okay, color change, color change, color change. So if you
Yeah.
look, it's an event source
Yeah.
kind of like system, right? So, and because we are touching on one of our nice topics, and I'm looking, we have 5 minutes till the end. Probably, I would like for us to jam on something that we used to torture people in the past. That is, how can you build a distributed transactional system, like, for example, a bank? I mean, we are not in near farm anymore, so I don't think this question is asked
No, look, it
anymore.
was just us that created that question. So
So
but also, it's even worse than that. Okay, without having elves, working overnight to fix it. Okay, because the without clause is actually very important. Okay,
yeah,
the elves overnight to fix it is actually very, very critical to the point. And if you ever discuss about this, we'll talk about how the banks work, and you will discover there are elves in the overnight fixing things. So,
but I mean, we mentioned about event sourcing, and for the people that don't know, event sourcing means events-based state mutation, and those one are time consistent. But I think it's a super cool. Generally speaking, like, I'm super excited. I would just make another talk only about event source systems, but and we always ask the question, right? So, which system implements this model to actually mutate its state and do something? Like we usually ask about communication and orchestration, and we mentioned before, right? So, and probably everyone knows we're mentioning Kafka. I think actually when you think about like banks, it's super interesting that they use purely optimistic state value. Like we make a guesstimate based on a checkpoint that this is going to be your balance, and then during the night we're going to reconcile. And how we reconcile? We traverse all the event log and reprocess operation after operation, and we expect that the input result equals to the process result. If they are equal, then we have a guarantee that the transaction was correct, and so your balance is correct. Oh, I forgot to mention, the balance is your state.
of course,
I mean, right.
But it's the only thing that matters to you. Consider all things considered. How much is it in your bank account?
Correct, because you don't care about your transactions, right? Your
Zero.
transaction, they result into a state mutation, so your balance mutation. I think that's actually the beauty of this system. So event sourcing is another interesting technique when you want to have those kind of like large scale, um, kind of like when you want to take consistency out of the equation, and then consistent will be eventual. So clearly, eventually I will make it consistent. So the
Yes.
night process. Oh yeah, probably, Theo, we have like a minute. Strong consistency against eventual consistency. Pro, cons,
Slow
why?
versus fast. So it's very simple to say, okay, I'll do a write. I write something in my database over there. It's fine. Okay. It will be fast. Okay. That will be fast. Okay. But
However,
then, it might also be incorrect. Okay. And somebody then will say, maybe no, maybe you don't. Maybe no, maybe you don't have this money on your bank account. This was a mistake. Okay. And then things will be fixed up later on. Okay. Now that is the key. Okay. Of the a key distinction. Now, a system provides eventual consistent system. Eventually, the state will solidify into something that everybody can agree on. Okay, yeah. Eventually, at some point in the future. Okay, which means that you're fine. Like if this is acceptable to your user and your use case, this is absolutely fine and perfect. Okay.
Yeah.
But if this is not acceptable for your end user, you need strong consistency, which means that all your databases, all your servers needs to agree on whatever needs to be written, okay? Whatever is the value before putting it on disk and solidifying it. Now, the typical case is a social media or a social network, okay? It's fine. It can be eventual consistent. At some point, your post will be visible to everybody's timeline. Okay, probably not now. Okay, maybe in a minute. Okay, there was this long article on InfoQ on how Twitter at the time worked using Redis underneath, and they had one queue for each user, one list for each user showing their timeline. Okay, and when the new post came up, they were literally adding one entry in each one of the user timelines, which makes loading the user timeline super fast. Publishing was super slow. Okay. But it was a total trade-off. So when you were publishing a thing, it will need to publish it to all the queue, to all the timelines. Yeah. Super perfect. Okay. No problem whatsoever. But it will take some time. Okay. And so, it could fail, it could restart. So you can have duplicate posts, and you will back in the days, you will see sometimes duplicate posts in your timeline. Okay. It's fine. Okay. So yeah, this is very, very nice, I would say, on that side of things. So
yeah, and it allows actually to kind of like have flexibility, right? Because if a system would be to always be strongly consistent, like probably a medical device should be strongly consistent, right? Or something that is kind of like of high value, but when you have a high volume and you can compromise the tiny kind of like variance in the state, it's okay. I think in most cases, even if banks, there is a distinction actually in banks when you do a cashier check. Actually, that's strongly consistent, but credit cards are eventually consistent.
Yeah, right? Absolutely. Okay, it's fantastic. Credit cards are fantastic. So at some point they will reconcile, but it's I love it. Now there is the gist part. If you have one of the old ones with the numbers embossed, okay, those are eventually consistent. That's fine. But then there is the online credit cards. They are not. In fact, they are actually validated at that time that there is money on. It's like a debit card in that sense. Okay, yeah. Which is great, to be honest.
Yeah, we implement the same system when I was in Amsterdam. Like you usually do a get balance, and you have like a get balance with a guesstimate, and try to basically see if this transaction will fit in that balance, and that's probably the interesting kind of like approach. But we are on time, Theo, and I know that you and I could actually talk for days about
So I have a couple of good news that I cannot share, but I have a couple of good news at the same time. So this is very lucky call, Luca. So
good. Do you want to share anything?
No, one is private, one is for Platformatic, still private still.
Good.
It's a good one. So guys, stay tuned.
So while you stay tuned, don't forget to submit the topic we would like to chat about next week. And we also have a surprise for you coming very soon. Just hold on. For this particular format, you will probably see some slight changes and we will make it a little bit more interactive. Till then, I want to wish everyone, first of all, if anybody has any question, post it. We're going to answer. We are always trying to reply to every single question. And I'm inviting everyone to tune in again next week, same time, same place, with Matteo and I. Till then, ciao.
Bye, guys. Bye-bye.
Ciao.